Hi everyone, today we will learn a classic problem which is longest common substring. Between two strings, we will be given two strings. Let me show you. We have a main method and we'll have two strings. Let's say str1, let's say s1 equal to, I'm giving JITENDRA, and the second string is s2 to JITU. Now what we will have to do here, we'll have to compare in both the strings s1 and s2, and we have to check what is the longest common string. If we look here in s1 and s2, we can see that the JIT, the 3, uh, the length is 3, the longest common string is JIT. So that is we have to do by using, we'll use loop here, we'll use nested loops here, we'll create a program to solve this problem, and we'll use DP. Diagonally we will save, we'll have two dimensional array, we'll create two dimensional array, we'll save the data, but the data, the length we will save diagonally. That is the TP problem. We'll use that concept in here. Okay, so I'll start writing it. Let's see what it gives us. So I'm writing method public static string because we have to return a string. Then let's give the method name longest substring. Longest substring. Now it will accept two arguments, which is string 1 and string 2. String s2. Now let's return null for now so that it does not give any error. Okay. Now let's proceed. So what we'll do, the very first I will create one int dp array, which is two-dimensional array, new int, and the size of this array would be the length of this string plus 1. Why plus 1? I'll show you. S dot length plus 1, and second s2 dot plus 1. Okay, we have taken plus 1 because the index starts with 0. That's why we have increased the length to 1. Let's say if we have index 0 to 9, so what would be the length of this? 0 to 9 is 10, right? So that's why I have increased to this to plus 1. Okay, right. So next step is to have two variable in, let's say first variable we are creating to get the max length, and we'll initialize it with the 0. We'll give 0 value. Initially it has no max length, 0. And the next is end index, which will have to find out the start value. The end index will be used to interpret, to check what would be our start index or end index. End index would be the index where it is ending, the common substring is ending, and the max length would be the length of the longest substring, which would be 3 in this case, as we can see, and the start index would be the end index minus max length. So that would be our start index. This is what we are going to implement here. Okay, so let's start with the for loop, and we'll have int I equal to 1. We'll start with 1, and I less than s1 dot length, and I plus plus. Okay, now the nested next loop int j equal to 1, and j is less than s2 dot length. Now why we have taken I and j for s1 and s2? Let me tell you that, because we are going to compare the character at s1 index and character at s2 string index. Okay, so we'll compare both here. So let's say, for example, if we are comparing I to j, s1 to s2, we'll check, the very first step will check if dp, now the dp s1, because we're comparing s1 and s2, no? So s1 dot caret I equal to s2 dot caret j. So not j, we will check the previous one because index started with 0, right? We will check the previous one. So the very first step, the line number 22 says that we are comparing s1 dot caret I minus 1, which is I would be 1 in this case and j would be 1 in this case. Okay, so I minus 1 would be 0. So we are comparing this first, this j letter in s2 and j letter in s1, which is the 0th index. Okay, so we are comparing both if it is equal, and in our case it is equal, so it will come into this if block and it will check further, not it will check, it will save the data. We'll update our dp array, which would be I and j. At the I and j position, we will have the value dp I minus 1 and dp of j, not j, this would be j minus 1 like this, plus 1. What we have done here in dp, what we are doing, we are increasing the count. So let's say it has given the value 0. So 0 plus 1 would be 1. The dp of I and j would be, the value would be 1 here. So I and j are what here? So it would be, I cannot show you the visualization here, but let's suppose we have 2D array. So 2D array would look like this. So 1, 1, let's say I'm giving 1 only every time. So it would look like this, right? Right. So in this array, what we are doing, we are putting the value of I minus 1 and j minus 1 plus 1 in the ij position. So let me explain you. dp of 1 and 1 would be the position, I would be 1, so 0 and 1, it would be 1 here, and j would be 1, 0, 1 as well as, so 0, 1. So let's say this is the ith or this is the jth, so 1, 1 would be on this place. So we have updated 1 here, or everywhere it would be 0, right? So next time when it will go diagonally, it will be going to update the value. So let's say it matches again, in our case it is matching, so what it will do, it will update the 1 to 2 again. So what it is taking, it is taking I minus 1, so I minus 1 would be this value, and it will add the value 1, add 1 in the previous value, so it would be 2, and similarly it will go. So this you will have to visualize, you will have to check what is TP, what is diagonally you have to do. In this video we do not have the scope to make you understand the dynamic 2D array here, so I'll simply explain you how we can solve this problem. Okay, so let's say we have done this, now this is done. The next step would be, we will check if dp of I and dp of j is greater than max length. So for example, we have done 1, updated 2 in the next diagonal position here, I have shown you that. So that we will check here if it is greater than max length, which is we are trying to find out here. If it is greater than max length, so what we will do, we will just directly update our max length with the new greater length, right? And at the same time we'll find the end index, so which would be 1, which would be the current ith index in that case, because it is the nested, it will run the loop for the next number of times whatever j is there, and this I will keep track of the indexes of this where we are iterating. Okay, so it would be our end index, so it will keep updating until we find the longest substring. Okay, and index would be, we'll update it to I, right? So this is our end index. Okay, now done. Now this problem is done. Now what we'll have to do, we'll have to use end index and max length to get the substring. So what we'll do s1, because the s1 is the biggest, the bigger substring between these two, s1 and s2. So we'll have s1 to get the substring, and we'll give begin index or end index. So begin index would be what? It would be end index. End index would be bigger in number, and max length. Max length would be 3, because it is being updated as per the 2D array. Okay, so this is max length. Okay, so we have updated this. Now it will give us the substring, right? Now let's call this function and let's see what it is giving to us. Is it correct or not? Okay, so yes, so longest substring. Okay, so it is giving JIT. So that's what we are trying to see here. So let me explain you. You might struggle between these two steps. Okay, so this step is very easy. Whenever we find a match, we'll just go inside and we'll update the dynamic array, which is 2D array. And in 2D array, whenever we are updating, we are also comparing the max length with the current value.